Okay, just wait, I am starting. Okay, so we have discussed that is a data hold certificate. That is a data hold. So first of all, you have to do this data hold circuit. That is a data hold is a process of generating a continuous time signal that is also ht from a discrete time signal. Discrete time signals or sequence, signal or sequence, these are the basically same thing. Sequence that is x of at. So a hold circuit convert the sampled signal into a continuous time signal. Okay, and these signals basically it has a one of the ranges it is available. So the signal that is also ht during the time interval that is kt are less than equal to the t small t, it is also less than k plus 1. Okay, so and it is basically express the polynomial. So this t may be approximated by a polynomial in tau. We have to express that is tau. Tau as follows. So the equation that is h of kt plus tau, this is the symbol of tau, is equal to a n tau to the power n plus a n minus 1 tau n minus to the power n minus 1 plus dot dot dot. This is a1 into tau plus a0. This is the equation number 1. Okay, so this is the basically data hold circuit. What is the data hold circuit? Data hold, it is basically process of generating a continuous time signals. This is expressed, that is ht, from a discrete time signal, that is x of kt. Okay, so this data hold circuit you have to use is data hold. It changes the continuous time signals, that is ht, into the from a discrete time control signals. Okay, that is it. And hold circuit, it is basically convert the sample signal into a continuous time signal. So when you have to use the different types of modulator or demodulator circuit, that is which is modulate and demodulate the different types of signals in our communication satellite purpose or communication purpose, we have to use this data hold circuit. Using this data hold circuit, it is basically changes the continuous time signals, it is from the discrete time signals, and hold circuit, it is basically changes during the time interval to the the hold circuit converts the sample signal into a continuous time signal. So this is the basically range. So using the range, we have to convert here polynomial functions. It is expressed as there is a tau, that is h of kt plus tau. This is the first term, a in tau to the power n plus a n minus 1 tau to the power n minus 1 dot dot last term, that is the e of 0. Okay, now where 0 less than, that is tau, it is less than also capital T. Note that signal hkt must equal h of kt. That means h of kt, this is equal to x of kt. Now, next page we have to go. Equation 1 can be written as follows. You know the equation 1, this one. Okay, we have to written these equations, that is h kt plus tau is equal to a n tau to the power n, 1 minute, tau to the power n plus, you know that next term a n minus 1 tau n minus 1 plus dot 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 plus a1 tau plus x of kt, different values of the k. So equation number 2. So in this data hold circuit, it is basically nth order polynomial functions, and it is called the nth order hold. So if the data hold circuit is an nth order polynomial extrafloater, this is called polynomial extrafloater. Okay, it is called an nth ordered hold circuit. Hold circuit. Okay, so that means when n is equal to 1, it is called first order hold. First order hold circuit. Okay, and so on. This process is continuing. So this nth order hold circuit is basically first order we have to convert when n is equal to 1, and so on. This process is continuing for the different types of different signals. So now we have to retain these equations. The simplest data hold is obtained when n is equal to 0 in equation 2. This equation 2, that is h is equal to kt plus tau is equal to x of kt. This is again equation number 3. Okay. So what is the basically equation is coming? We express the one graphical diagram. So here this range, it is also written 0 less than is equal to tau less than t, and different k value, you know that. Okay. So this circuit, it is basically hold implies that the circuit holds the amplitude of the sample from one sampling instant to the next. Okay, so a data hold circuit is basically called, next one. So a data hold is called a zero order hold, or sometimes it is called clamper, data clamper, or sometimes it is called staircase generator. Staircase generator. So please remember these topics, these terms, because these are the basically same things. Zero order hold, or it is called the clamper circuit, or it is called the staircase generator. So I am drawing the diagram, then you have to clear the idea. First of all, this one is for the continuous time signal. Then this is the basically discrete time control system. Then it is the data hold circuit diagram, something like that. So this is a x of t, starting point 0, that is t. This is the basically different value of the k, that is the x of kt, 0, that is also kt. Another one, you know that this is the ht for the zero order hold circuit, and this is the 0. So now the diagram is something like that. This one. Okay. Now you have to change this equation into the output. First, that is a 0, then t, 3t, 4t, 5t, then also 60, and so on. Okay. Zero, t, 2t, 3t, 4t, 5t. So these are the different value we have to convert using the impulse sampler functions. This one to this one also. Okay. And another one. This is basically staircase functions. First, sorry. Okay. First, this one, this one, this one, then this one, this one, and so on. So this process, okay. So this is basically called the staircase functions or staircase generator or clamper or zero order hold circuit. So sometimes, so what is the basically circuit diagram of the sampler or zero order hold? I'm written here. First input, one on off button, that is also one another block it is again, that is the zero order hold, then is the finally output from here. So this is a continuous time signals. You know that xt sampler here x of kt inputted here at a zero order hold block, then the finally output, that is h of. Okay, is it clear all of you? What is zero order hold and how it is calculated? So this is the another important questions for the zero order hold circuits. Is it okay? No one is confirmed. Is it okay or not?
Yes, sir.
Okay. So now we have to consider, we have to write the transfer functions of the zero order hold circuit. Okay. So the transfer functions, we consider here, that is gh. Okay, for the transfer function, you know that we have to express, that is gs. Okay, g h for that is a zero order hold circuit. So gh of the zero order hold may be given by, so this is gh, this is equal to 1 minus e to the power minus of ts by s. So please remember these things also. This is the basically transfer functions of the zero order hold circuit. Okay. So this is the data hold circuit and how it is calculated, and zero order hold circuit, what is the transfer function of the zero order hold circuit also. Okay, so now we have to obtain the transfer functions That is the transfer function of the zero order whole circuit. So how it is calculated? So I am given the explain in the next page. So consider the sampler and zero order hold shown in figure A and figure B. So I am drawing the figure. This is basically input, one switching button. Then we know that this is the previous one we have to draw. This is the out. So this is a H1T. This is a zero order hold XT, capital T, here X of T. Okay. This is the figure A. This is a real sampler and zero order hold. Okay. And another one figure. So please remember same thing. Then this is the output. So this is a continuous time signal xt, and this is a sampler x of t, impulse sampler, that is x of t. You know that this is t, small t, and that is also x of s. G, transfer function of the zero order hold. That's why we have to written here is zero. That is also H2T function is H2. So now this is a figure B, mathematical model that consists of an impulse sampler and and transfer functions, that is g of a zeros of. Okay, so now we have to calculate first of all a real sampler of zero order whole circuit from the event transfer functions. Another one, mathematical model we have to consider here is the transfer function of G0 of the systems. So now how it is calculated once again. So assume that the signal x of t is 0 for t less than 0. Then the output, that is h1t, is related to x of t. You know that. So now we have to written this equation h of t. This is equal to x of 0, that is 1 of t minus 1 of t minus capital T. This is the for the first function, that is k is equal to 0. Then k is equal to, when k is equal to 1, that means x of t, that is 1 of same thing, t minus capital T minus 1 into t minus 2t. Okay, then plus x of 2t into 1 of t minus 2t minus 1 t minus 3t. Okay, so first of all t minus t, then t minus, sorry, t minus 2t, then t minus 3t, and so on. This process is continuing up to the infinite term. So now we have to written this equation, that is the summation of, you know, that is k is equal to 0 to infinity x of kt, that is 1 minus, sorry, 1 into t minus, that is 1 into t minus kt. This k, it is changes, you know that different values of k, minus 1 into t minus k plus 1 into capital. So this is the basically functions, that is the equation number here, it is 1. Okay, so now we have to apply that Laplace transform, that is since Laplace transform of 1 into t minus kt, this is equal to, we have to know the from the Laplace transform table or formula. This one is the functions, that is the changes of the value, that is e to the power minus kts by s. Now we have to put this value into this equation number 1. So I am going the next page. The Laplace transform of equation 1 becomes, now we have to apply the Laplace transform into this equation. This is the basically equation number 1. That is, you know that h1t becomes, the equation is coming Laplace of h1e is equal to, we written that is h1s. This is equal to summation of k is equal to 0 to infinity x of kt. The, when you have to apply the formula is coming e to the power minus kts minus e to the power k plus 1 into capital Ts. Okay, this value it is changes for the different value of the k divided by s. So now we have to simplify these equations. 1 minus e to the power Ts by s. This is summation of k is equal to 0 to infinite x of kt, and rest of the term e to the power k minus of k ts. That means e to the power minus k ts. This is the equation number 2 for the this zero order whole circuit. Next, we have to consider this mathematical model for the previous diagram. That is the mathematical. This is the mathematical. Sorry, this is the mathematical model of the functions of the transfer function of the g, z, h0 of s. So here, these functions. This is the basically mathematical functions of the figure B, and the output of this model. The output of this model must be the same as that of the real zero order whole. That means we have to retain Laplace of h2t t, this is equal to h2 or s, that is h what is. Okay, now we have to written this equation, that is h2s, this is equal to 1 minus e to the power minus ts, this is e by s, a summation of k is equal to 0 to infinity. 1 minute. K to infinity, that is x of kt e to the power minus k ts. This is the equation number 3. Okay. Now from figure B, we have draw the previous page. That is the first one. That is from figure B, we have, that is H2S. This is equal to G of H0S into S asterisk of S. Yeah, you have to see in this diagram, previous one. Sorry, this one. So here we have to retain, that is H2S. This is equal to Z H0S into X of S. This one the function of the XS of the H2S also. Okay, so that's why we have to retain, sorry, that is the H2S. This is equal to G of H0S into X asterisk of S. This is another number function. I think that is the equation number 4. Equation number 4. Since we have to retain, that is X asterisk of S, a summation of k is equal to 0 to infinity x of kt into e to the power minus kts. You know that? So equation previous one, this one, that is equation 3. Equation 3 may be written as, that is H2S 1 minus e to the power es by s x asterisk of s, because here the s asterisk of value of this one, so that's why we have to put this value into the equation number 3. The equation is coming this pattern, that is equation number 5. So now by comparing equation number 4 and equation number 5, we see that the transfer functions of the zero order whole may be given by that is g of sorry, g of H0S, that is equal to 1 minus e to the power ts by s. Okay, so this is the basically equation transfer functions of the zero order whole circuit. Okay, so This is very, very important for your exam. Okay, so please everyone note down it. क्वेश्चन ऐसे आप लोगों को आएगा, derive the transfer functions of the zero order whole circuit. Okay, derive the transfer functions. Derive the transfer functions of the zero order whole circuit. Okay, अभी आपको ये डिस्क्राइब करना होगा. ओके, सो ये बड़ा एक क्वेश्चन आ सकता है आप लोगों का एग्जाम में. यहाँ से स्टार्ट होगा आप लोगों को. दिस वन previously you have to draw these two diagram. First one is the real sampler functions for the zero order hold. Then you have to apply the mathematical expressions for the zero order hold circuit. Okay, then you have to consider this mathematical part. Okay, is this clear all of you? कोई रिस्पांस नहीं दे रहा है, मतलब ये क्लियर नहीं, नॉट क्लियर. Okay, everyone, please write your own name and roll number in the chat box also. And Saurabh, to take a screenshot. And after ending the class, you have to send me both screenshots. Saurabh, please respond me. Are you hearing me?
Yes, sir.
Okay, you take a screenshot. Okay, so tomorrow Saturday I take one class, single class, okay, on 10:20 from 10:20, okay, because in your Tuesday class is missing from my laptop, it is does not working, so that's why I take one class, single class on Saturday 10:20, okay. So please everyone join the class also, Saturday 10:20. Okay, so we have covered the jet plane analysis of the discrete time control system. First, we have to discuss the impulse sampling method, how it is calculated. Then number two, we have to discuss the data hold circuit. What is data hold circuit? Why, how it is calculated also. And third term, this is the very, very important zero order hold for the jet transfer method. That means the how transfer function is calculated from the zero order hold circuit. In your syllabus, the zero order hold circuit is present. Okay, and the rest of the topics we have to discuss for the next classes. Pulse transfer function of closed loop control system. Okay, tomorrow we have to discuss the another next topics, pulse transfer functions for the closed loop system. So there are two or three, that is a two agents, two topics are available from this module. Then this module it is ended, and I think next next week we have to discuss the another new module, module 3, steps-based analysis. Okay, so I have uploaded the class notes in your Google Classroom portal. So everyone go through the Google Classroom portal and read it carefully. Anyone any doubt or any confusion, so please tell me through the Google Classroom portal or WhatsApp group. Then we have to take one remedial class for the doubt clearance. Okay, and I am given the class notes, that is the description of the details in the class notes from the books is available, or whatever we have to design from the internet also, and uploaded by the end of the day. Okay, so everyone go through the Google Classroom and follow the Google Classroom portal. Is it okay, all of you? Okay, so today's time is less than 1 minute, so everyone write your own name and roll number in the chat box also. So thanks everyone. We will meet the next class on Saturday, that is tomorrow from 10:20. Okay. Anyone, any question or any doubts, so please ask me. Otherwise, I conclude the session. No doubt.